Hi friends, welcome to the video of Truth Table Part 2. In the present video, we will discuss about construction of truth table of a compound statement, conditional and biconditional statement. Also, the definition of tautology and contradiction will be discussed and explained with the help of some examples. At the end of this video, you will be able to construct truth table for compound statement, truth table for conditional statement, truth table for biconditional statement, and you will define tautology. So let's define the truth table for the compound statement. As we know, truth table is the combination of different statements. So basically, the truth table for the compound statement is nothing but the truth table for conjunction, disjunction, and negation. Let's consider an example to understand the truth table for the compound statement. Suppose you have two statements, P and Q, and their truth values are T, 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 F, F, T, F, F. So by using the earlier knowledge, we know that the truth table for minus P, if the truth table for P is T, for negation of P, it is false. So for minus P, it is false, false, true, true, because the original values has T, T, F, F. So minus P has a value F, F, T, T. Similar for the case of Q also. So minus Q is F, T, F, T. Now we will find the conjunction of minus P and minus Q. So you have noticed that the conjunction of two statements has a truth value true only when both the statements has a truth value T. And in all other cases, its truth value is false. So in this column, because minus P is F, minus Q is F, so truth value is going to be F. The second row, minus P is F, minus Q is T, so the truth value is F. Third, it is TF, so again it is F. And the last one, since both are true, so the conclusion is true. So the last row, it is true. Now what we want is negation of minus P and minus Q. So whatever will be, it is there, F, 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 T, its negation will be T, 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 F. So this is an example of one truth table for the compound statement. Let us construct the truth table for the conditional statements. Just like we have constructed the truth table for the compound statements, similarly, we will apply some rules to construct the truth table for the conditional statements. So if P and Q are two statements, their conditional statement will be if P then Q. And what is the rule for constructing the truth table for the conditional statement? It says that the condition P implies Q is false if P is true and Q is false. And in all rest of the cases, it is going to be true. So step 1, P and Q, and with the different truth values T, 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 F, F, T, F, F. So when the P implies Q is going to be true, it is true for T, T, F, T, F, F. And it is false only when the P is T and the Q is false. So this is what we get in the final column. So let us consider the example for the truth value for the conditional statement. Look at this example. Here you have different values for P and Q, true and false values. Since P having the truth values T, T, F, F, minus P have the truth value F, F, T, T, the negation of P. So let's find out the truth value for minus P implies Q. Just remember the formula. It says that it has the truth value F only when the first statement is true and the second statement is false. And in rest of all cases, it is going to be true. So you can see at this diagram that in the last row, only the first one is true and the second one is false. So the result is going to be false. And in rest of the cases, it is T. So minus P implies Q is T, T, T and F. And what would be the negation of this whole column? It is going to be F, 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 T. Let us define the truth value for the biconditional statement. For constructing the truth value for the biconditional statement, there is also a rule which says that the biconditional statement P if and only if Q is true whenever P and Q have same truth values. That is, if P and Q have T together or P and Q have F together, then and only then the P if and only if Q is going to be true, and in rest of the cases it is going to be false. Look at this steps. P and Q, they have different truth values, and their biconditional column, first row and the last row, they have the same truth value TT and FF. So their conclusion is going to be TT, and in the second and the third row, these have different truth values TF and FT, so the conclusion is false. Let's make a table for the biconditional statement. You have the statements P and Q with the different truth values. We will make a column for minus Q also. Whatever will be the value of Q, take the negation of that one. If it is T, it is going to be false. If it is F, it is going to be T. So in this way, we are making a column minus Q. Now let's find out how to make the column P if and only if minus Q. P is T and Q is F. Note that here P is T and minus Q is F. So their conclusion is going to be false, because here both the statements doesn't have the same truth value. Similarly, moving to the next row, P is T and minus Q is T. So here the conclusion is going to be T. For the third one, both have the same values FF, so it is going to be T. The fourth one, it is F and T, so conclusion is false. And if we are going to take the negation, it comes out to be TFFT. Now let's define what do you mean by tautology. A statement is said to be tautology if its truth value is true for all logical possibilities. That is, if we are making a table for the tautology, the final concluding column in that table should be T only. Then we will say that this table is a tautology. Let's study it with the help of an example. You have a statement P with the truth values T and F, and its negation is minus P having the truth value F and T. So what would be P or minus P? So you know that when in case of disjunction, it is false only when both the statements are false, and in all other statements, it is going to be true. So here TF, conclusion is T, FT, conclusion is T. If there would be a row like FF, then the conclusion will be false. So we don't have such row. So look at this table, you will find out that the last column, it consists only T, no F. So this is an example of tautology. Contradiction. What do you mean by contradiction? Just like tautology, it is a statement where all the truth values should be true. Similarly, for the contradiction, all the truth values should be false. That is, a statement is said to be contradiction if its truth value is F and only F in the last column of its truth value. Let's consider example. So here P have truth value TF, minus P has truth value FT. Let us find out the conjunction for this one. For the conjunction, apply the rules. You will find that T and F is going to be F here. F and T, it is F here. So the last column has F values only, no T values. So this is an example of contradiction. Key points discussed in this video are truth table for the compound statement with the help of examples, truth table for conditional statement with the help of examples, truth table for biconditional statement with the help of examples, and tautology and contradiction are also discussed here with the help of examples. Now, how can you use this? Since in this video we discussed about the truth table for the compound statement, conditional statement and biconditional statement, tautology and contradiction, it is quite helpful in the program designing.